Welcome back, ladies and gentlemen. Today we're going to talk about section 8.5b, day 2. It's all about kites today. Up on the screen, you'll see your exit question. Let's start with a good definition. First off, our kite is a quadrilateral that has two pairs of consecutive congruent sides, but opposite sides are not congruent. This is kind of a weird definition because most definitions are phrased entirely in the positive, but the kite definition has a restriction on it that says the opposite sides cannot be congruent. And what that does is it forces a kite to be unable to be a rhombus. So there is no intersection between rhombi and kites. It just doesn't exist. So the kite definition excludes the situation where a kite could be a rhombus. Next up, we have a couple of theorems and a couple of corollaries. The first theorem we have is theorem 8.18, and it simply says that the diagonals of a kite are perpendicular, that they form a right angle, and you can use that information. What's really nice about that is that you'll often know an angle in here and you can do some trigonometry, or we can actually do two quick corollaries off of that. Because this splits it up into four right triangles, you can actually apply the hypotenuse leg congruency theorem very easily and very quickly because you have a shared leg. So through the reflexive property, that's the same. You have the hypotenuse being equal and you have a 90-degree angle. So therefore, these two triangles and these two triangles or this triangle and this triangle are congruent to each other. And likewise, by the same argument, you can make the fact that these two triangles are congruent to each other. Now, that has two very interesting corollaries because if these two triangles are congruent, then all of their corresponding parts are also congruent, which means that we can say anything about any of the corresponding parts of those two congruent triangles. Namely, the useful ones are that this angle corresponds to this angle. So when the diagonal bisects the kite in this way, it bisects the angles between the two congruent consecutive sides. So this angle right here is bisected. CDA is bisected. The second part of the corollary is about this diagonal right here. Now this diagonal is clearly not split in half, but this one has a set of congruent triangles and it is a corresponding leg from one triangle to another. So that length is the same. So the corollary very quickly using the hypotenuse leg theorem is that exactly one of the diagonals, but not both, is bisected. Next up is theorem 8.19, and it simply says that there is exactly one pair of opposite angles that are congruent in a kite. Not two pairs, exactly one pair. These angles, these opposing angles, will not be congruent to each other by definition. Okay, time for our first example. And it doesn't look like I gave you a whole lot of information there, but it is totally possible to find the perimeter of that kite. Why don't you pause the video and see if you can work that out? There's several steps to this problem, but give it a shot. Okay, first thing to do, I would draw in that diagonal. There's a couple things you can say right off the bat with this diagonal. We immediately start chopping this 10 in half into a 5 and 5. But also what happens is we chop this angle and this angle in half. So that's a 90-degree chopped in half, so we'll get 45 and 45. This is a 60-degree angle, so we'll chop it in half and get a 30 and 30. And that means that we can fill in the rest of the angles as well. So if this is, because these are diagonals, they are at 90 degrees. Therefore, we've got a 45, 45, 90 and a 30, 60, 90. Hey, those are special triangles. I bet we can figure out the perimeter without having to do Pythagorean theorem. How awesome is that? Okay, so this diagonal is bisected, which means that half of it should be 5. And since half of it is 5 and these are 45, 45 isosceles triangles, we can put that 5 right over here as well. Now comes the trig ratios that I told you all to memorize. And if I want the hypotenuse here, this is the short leg of a 30, 60, 90. So the hypotenuse is always twice as long. So this hypotenuse right here is 10. And for the 45, 45, 90, here's our leg. To find the hypotenuse, we just always multiply by the square root of 2. So the hypotenuses will be 5 times the square root of 2 and 10. And that gives us the perimeter of the kite. So all we have to do is add that, plus that, plus that, plus that, which would be 10 times the square root of 2 plus 20, or if you converted it into a decimal form, it's 34.14. Next example. Sounds simple. Show that VRST is a kite. Pause the video and see if you can determine exactly what conditions you must satisfy to show that something is a kite. To show something is a kite, you have to show that there's two sets of consecutive congruent sides, and you have to show that those two sets of congruent consecutive sides are not equal to each other, because we can't have any opposing sides equal to each other. So in order to do this problem, we have to do 4 distance formulas. We have to find the distance of each segment. And unfortunately, all of the segments are askew, so you have to do it the long way using the distance formula, even though you should be able to see at least a couple, 3, 4, 5 right triangles in there. So RS would be 2 minus 4 squared plus 3 minus 4 squared. So here you have 2 squared, 1 squared, for a total of 5 underneath the radical. If you do the same thing for ST, you get 4 minus 3, which is 1, and 4 minus 2, which is 2. So again, you get 5 under the radical after doing all that work. Then we'll go for the longer sides here. We're hoping that these two things are equal. So TV distance formula looks like that, 3 plus 1 squared and 2 plus 1 squared, which would give you 25 under the radical. Now notice that you could also draw a 3, 4, 5 right triangle to find that hypotenuse right there. So it makes sense that it's a nice rational whole number. And then our last one is RV, which is also 5, and you can see there 3, 4, 5 right triangle by doing that right there. So distance formula gets there every time, rather than having to search out these Pythagorean triples on a coordinate grid. Okay, just by doing those 4 calculations, that's enough. We just have to do a little bit of explaining here. We simply have to state that, hey, these two are equal, that's good, they're consecutive. These two are equal, that's good, they're consecutive, but they're also not equal to each other. And we can get this done in one very condensed statement. So take a look at this statement right here. It says that RS equals ST, and both of those are not equal to TV and VR, and TV and VR are equal. So all within that little symbology right there, that states everything that you need to say. I've thrown in some extra explanation here that says since VRST has 2 pairs of consecutive congruent sides and its opposite sides are not congruent, it must by definition be a kite. That wraps it up for today. Here's the assignment and the details of how to do it the best. I'll see you next time.